So today I'm going to be talking about potentiometers, and I believe it's a really fundamental part of electronics, and it's a really basic part. However, it's very versatile and used almost everywhere in projects, and especially in commercial cases such as uh, electricity flowing into a room where you want to change the brightness, such as the sliders where you have on your switches in the room where you want to change the brightness, well, you can just slide it up and down. That's exactly how it works. It's a potentiometer. It's common that potentiometers, especially like these, have 3 pins. So all these are 3-pin potentiometers, except this one, but those other two are just to hold it down into the board. So you usually have these two outer ones, or one that is separate from the others. So let's say if you take this one, you have one that's on this side, which is on the left side, and this other leg, which is on the right side. So you would, let's say, put ground on this side and 5 volts on this pin, and the middle pin is your variable pin. And depending on where that rotary knob is kind of rotated, well, you're going to get a different voltage output as well as a different current flow from that pin. It's all basic Ohm's law, and that's exactly how it works. It's basically you have a line of resistance going around your potentiometer, and depending on where that knob is located, well, it's going to take the shortest path to your ground. So if your knob is located all the way to the ground pin, which it is now, well, that means that the 5 volts has to cross your entire resistance line and then go into ground. In this case, they're all 10k ohm potentiometers, meaning that the maximum resistance that these potentiometers actually have is 10k. So this one is a standard potentiometer you'd see like in a lot of Arduino projects. It's not really powerful, it's not really the best, but it definitely works. But I do not recommend it for other complex. However, I do recommend these three. This is a common one you see. This is a 10k potentiometer. They're all the same, even though they look more industrial. I could remove the knob, and this is what it looks like. It's basically a metal knob with some sort of lubricant, because these are actually quite smooth when you turn them. Some sort of lubricant inside a slider, where you have a metal wiper, which is called in this case, which just goes around and changes the variable resistance of the middle pin. The same thing goes with this one. However, this one you see has 2 extra legs, but that doesn't change anything. That's just for it to be mounted on, let's say, a PCB or something, or a breadboard. This last one is used a lot, let's say, at school projects or just general purpose projects. It has a little arrow, which I like a lot. The first one also had something like that included in the package, but this one has a little arrow, which is easier to know where it's located. However, it's definitely not as smooth. It has a lot more friction. And I'm going to go through some practicalities today, especially using the Arduino Uno, which is a classic. But you can really use a potentiometer without any microcontroller, and that's really what makes it really important, and to lower the complexity of electrical circuits, is to use these directly onto lines, and as opposed to your standard fixed resistors. Let's say this 220 ohm resistor, I believe, or no, something else. The fixed resistor is, as the name suggests, is fixed. So it can only have a single value of resistance. So if we assume that this is 220 ohms, well, that's what it's going to be for your entire circuit. It's going to be 220 ohms. However, if you replace this fixed resistor with a potentiometer, well, you can have anywhere from 0 all the way to 10k ohms. But I don't suggest using a 10k ohm resistor to replace a 220 ohm, because the moment you turn the knob, it's already going to be surpassing your 220 ohm value. So that's why there is potentiometers that are for sale with different values, such as 1K, 500 ohms, or even 500,000 ohms, depending on your use case. So I'll be showing you exactly what you can do, hardware-wise and software-wise, to control different things such as servo motors or even the brightness of an LED with potentiometers. So here I have your standard LED, your 5mm THD LED. In this case it's a frosty white, which I really like. And it's connected to a pull-down resistor or current limiting resistor to ground. Now it really doesn't matter if you put the resistor before or after the cathode or anode. It's just if the total resistance is, in this case, 220 ohms plus a bit in the LED, well, it's going to current the resistance with Ohm's law, as this is just DC power. And this is just connected to 5 volts from the Arduino, so it's only pulling a couple of milliamps of current. But it is definitely drawing 5 volts is what it's delivering. And I'm going to be replacing this with a potentiometer, both hardware and software. So we're going to start with the hardware because that's what I recommend. The problem with using potentiometers like this one for software is that, well, whenever you encounter a problem, well, because you're using an Arduino and a microcontroller, everything is just going to become a software problem. So I'm going to switch this up into your standard hardware version of it. So a few seconds later, and I'm here with this circuit, and it's actually quite interesting. All I did is I bypassed the centerpiece here with a potentiometer. And if I just focus here, and all I'm doing is instead of the 5 volts going straight into the LED, I'm now running it into the potentiometer, and then I'm taking the variable voltage pin and putting that into the LED. So it's not direct anymore from the Arduino. The other pin of your potentiometer is connected to ground, and your right pin is connected to the 5 volts. And so now if I turn it slowly and slowly, you'll see the brightness of the LED increase. So now I'm actually at the 5 volt side. So all it's doing right now is taking the 5 volts, running it into the right pin of the potentiometer, but because it's turned all the way clockwise, well, it's almost a direct entrance to your variable voltage, and now it's 0 ohms. So it's like the potentiometer doesn't even exist right now. It's just going straight into the potentiometer, right out from the variable resistance pin and going into the LED. But now if I turn it, the fact that it's changing brightness is telling me that I'm increasing that distance. So because I turned it from here to here, I'm increasing that distance that the electrons have to travel, which increased by the resistance in the potentiometer. So I'm assuming that right now it's at around, let's say, 2K ohms of resistance. And if I go a bit more than that, well, it basically disappears. But you see how much more effective this is rather than software, because it's almost a real-time job. There's no processing going on. There's no code on this Arduino. And the fact of the matter is that right now this potentiometer, although analog, is not connected to any analog pins. So that is definitely, you see, it saves quite a bit of problems, both software and circuit-wise. So let's try this same thing, but software. So it's going to be the same thing where we turn on the knob like this, but instead of being connected to the LED, it's going to be connected to the Arduino with software, and we're going to take a look at that. So to set this up, the first thing you want to do is to actually connect the LED to a pulse width modulation pin. Now these pulse width modulation pins are some of the digital pins on the Arduino. So you can just connect that to let's say D11, because that I know is a pulse width modulation pin. The next thing you want to do is to connect one leg of your analog potentiometer to ground. The middle variable resisting pin of the potentiometer to pin A0. You want to also connect one of its legs, or the last leg, to 5 volts. And so now you have the circuit for your basic software-oriented potentiometer brightness level adjustment system. So you can also connect, it wouldn't be a bad thing to connect the ground to your ground rail. And that completes the circuit. So I have the Arduino IDE open up here. So the first thing I'm going to do is actually set up the global variables. I'm going to use the Arduino version of C++ so that it's more understandable. So let's just define the potentiometer pin first. So we're just going to define it as our pot pin, and that's connected to A0. The other pin we have to define is the LED pin. So that is pin 11. So we're going to just call it LED pin, and that's connected to digital pin 11, which actually has pulse width modulation according to the datasheet. Another value we're going to actually define, we can either define it within the void loop, but let's just call it here for best practices, and that is going to be our potentiometer value, which is not going to be declared here, but technically this is just considered as nothing. It's just 0, void. And let's just start with that, and if we need any more variables, then we'll just declare it afterwards. So here we have to say if what inputs are inputs or outputs. So that's just funny enough, but by doing this, we have to actually use the pin mode function, and let's just do that pot pin. Well, that's an input, so we have to actually write input, because that's taking data from the potentiometer into the Arduino. So nothing from the Arduino is actually being released and never coming back, so it's just input. For the LED pin, well, that is going to be an output, because we are going to be sending out pulse width modulation. We're actually not recording anything. So LED pin is an output. And that's it for setting up our pin modes. So let's go to void loop. This is going to be our loop program. Here, we're going to actually say pot val, which we declared up here, so we don't have to actually state if it's an integer, is equal to the analog read of potentiometer pin. Now you can put A0 here if you wanted to, but it's usually best practice to declare it up here in case you want to use it again. So that's our value, so we just put the value of pot pin inside of our pot val. How this is going to work is basically we're going to create a proportional graph, or a line, some sort of proportional line function, which basically says that if the potentiometer is set to 1023, which is the maximum, well, we also want the brightness of our LED to be maximum, so we want it to be 5 volts. And 5 volts to the Arduino is a high, so that's 255. And thankfully, Arduino actually saves us some time, as it has a function that is the map function. So we don't have to go through all that pesky little mathematics of finding the slope of a line and all that. It'll do it by itself. So we can just say that the pot value as volts, in this case, will be the function, so the map, you can think of it as a Cartesian map or something, is going to be our potentiometer value from 0 to 1023. So this is going to be our y-axis. You can think of it like that. So it goes from 0 to 1023. And we're going to set the LED from 0 to 255. So our y is going to be from 0 to 1023, and our x is going to be 0 to 255. And that's it, really, for our pot val. So now it's going to convert this as a function that's going to be sliding, and we're going to input that into our LED pin. So in this case, we're actually going to send an analog write to a pulse width modulation pin. And you can do that with Arduino. You can definitely do that. So you can do analog write to the LED pin, and we'll just declare it as the pot value. And now, whatever your pot value is, well, now instead of it being low or high, it's going to be from 0 to 255. Or, sorry, from 0 to 1023. As you are usually used to your digital right here, you're usually used to seeing high or low. Well, this is going to be our equivalent between the low and high. So 0 and 1. And let's just declare, so we have COM4, we have our proper board here, and our Arduino Nano, so let's just upload it here. So it doesn't seem like there's any issues with the program. And so I'm going to go back to the workbench, and we're going to take a look at what we have. So this is what it looks like after you upload your Arduino program onto your board. You'll see that the LED lights up, and when you turn the knob, well, you have that perfect kind of potentiometer, exactly like what you would think. And these are two independent systems from each other. Other than the ground being connected on the same rail, the potentiometer is not even connected to the LED, right? This is 5 volts, and this is just connected to a PWM pin on the Arduino. So we're just sending data from the potentiometer into the Arduino back out into the LED. So I hope this video was helpful to make you guys better understand what potentiometers are, some of its functionalities, and that they're convenient for bypassing any software problems, and you can just go directly into the hardware. And not to get confused with something like this, which is actually a rotary encoder, which even has a button functionality. I wouldn't doubt if you would be able to use this as a potentiometer, but this would mostly be hardware other than software. Software more than hardware. These are your standard resistors that you'd see, and these are fixed, meaning that these remain a single value throughout your system while these change. And that's it for potentiometers. Thank you. Thanks for watching, and let me know what you think. And stay tuned for the next video.